solve problems on queuing model 2 or birth-death process by using formulas.
Let us understand some important formulas related to model 2, which is symbolically represented as MM1 FCFS infinity, same as in model 1. So how we can differentiate this model 2 from model 1? So we know that in queuing model 1, arrival rate and service rate is independent on the number of customers waiting in line. But here in model 2, service rate and arrival rate depends on the length of queue or depends on the number of customers waiting in queue. So we have to show this lambda, that is lambda n, that is arrival rate, because it depends on the number of customers, and mu, that is mu n, because it depends on the number of customers waiting in line. So in model 2, lambda is greater than mu, that is arrival rate is greater than the service rate. This model 2 is also known as birth-death process. Now we will move to the important formulae. Here there are two cases. So arrival rate depends on the number of customers and service rate is fixed. This is the first case. So we can say that in this case, suppose case 1, lambda n is equal to lambda divided by n plus 1. So here lambda n, that is the arrival rate, decreases as the number of customers, that is n, increases. And service rate mu n is equal to mu, that is fixed. So it is independent on the number of customers. Now how we can understand this with example? Here arrival rate affects because of the number of customers waiting in line. Suppose we will take one example, that is the patients in hospital. Suppose all the beds are fulfilled with patients. Then the new patients arriving in the hospital will left that hospital and they will see the second option or the second hospital to serve themselves. So this is the example, that is the arrival rate affects because of the number of customers waiting in line. Now how we can write the formula for the probability of the number of customers in the system, that is Pn. So Pn, that is the probability of number of customers arriving in the system. So Pn is equal to rho raised to n divided by n factorial e raised to minus rho. Now what is the meaning of rho? So we know that is the utility factor. So rho is equal to lambda by mu. That is the ratio of lambda by mu. And how we can calculate Pn? That is the probability of number of customers arriving in system, rho raised to n divided by n factorial e raised to minus rho. Now we will move to the second case. So in the second case, arrival rate is fixed, that is arrival rate is independent of the number of customers waiting in line, but service rate will depends on the number of customers waiting in line, that is mu n is equal to n mu. So now if we observe this service rate, mu n is equal to n multiplied by mu, that is number of customers, number of service provided is equal to number of customers waiting in line. Now here if there are infinite number of customers, 1, 2, 3 up to infinity, then there may be infinite number of service provided, that is 1, 2, 3 and so on. So service, in this case service rate increases with increase in queue length. So how we can write the formula for probability of n number of customers in the system, that is probability of n number of customers arriving in the system, that is Pn is equal to rho raised to n divided by n factorial e raised to minus rho. So the same formula is used. So either service rate fixed or this arrival rate fixed. Same formula is used under all the questions for the model 2, and where rho is equal to lambda by mu. Now by using this Pn, we will find out the length of the system. So length of the system Ls is equal to summation of n is equal to 0 to infinity, because in model 2 infinite number of customers allowed in the system. So we have to take the limit from 0 to infinity npn, and pn we have to use this formula to calculate. And then waiting time in the system, that is Ws is equal to Ls by lambda. Now by using all these formulas we can solve the questions for the model 2.
We will read the first question. A shipping company has a single unloading dock with ships arriving in a Poisson fashion at an average rate of 3 per day. The unloading time distribution for a ship with n unloading crews is found to be exponential, with average unloading time 1 by 2n days. The company has a large labor supply without regular working hours and to avoid long waiting times. The company has a policy of using as many unloading crews as there are ships waiting in line or being unloaded. Find first the average number of unloading crews working at any time. Second, the probability that more than 4 crews will be needed.
Let us understand the given data. Arrival rate 3 ships per day, it is mentioned and it is fixed. Unloading time 1 divided by 2n per day. Now how to calculate unloading rate? So if we observe this question, here the service word is replaced with unloading process. So we can say that unloading rate or service rate is equal to 1 divided by unloading time. So unloading time is given, so we have to take 1 divided by 1 by 2n, and which is equal to 2n per day. So this is the service rate, or we can also say that unloading rate. Now we will write this given data with the help of notation. So this lambda is fixed. It does not depend on the value of n. So we will say that lambda is equal to 3 ships per day. But service rate depends on the value of n. So we will say that mu n is equal to n into mu. And mu n is equal to 2n per day as per the given data. Now if we observe this given data, arrival rate is fixed but the service rate depends on the value of n, that is the number of crews in line. So this question is under queuing model 2. Now we will move to the first question, expected number of unloading crews. So how to calculate the expected number of unloading crews? That is, we have to calculate the length of the system. So length of the system is equal to summation of n is equal to 0 to infinity npn. So npn, that is n is the number of unloading crews, and pn, that is the probability of n number of crews waiting in line. So how to calculate this probability? So we have formula that we have to put, that is summation of n is equal to 0 to infinity n, and instead of pn we will write rho raised to n divided by n factorial into e raised to minus rho. Now if we observe here, this n is the function of this n, that is number is varied from 0 to infinity. This rho raised to n, that is n, this is also variable, and n factor is also variable. So e raised to minus rho is constant, so we will take this outside this summation. So e raised to minus rho, summation of n is equal to 0 to infinity n into rho raised to n by n factorial. Now we will put the value. So how to solve this summation? So instead of n we have to put the values from 0, 1, 2 up to infinity. So I will write put n is equal to 0, 1, 2 up to infinity. So we have to put the value of n. So we will solve this. So e raised to minus rho inside the bracket. Now instead of n put 0. So first one is 0, e raised to 0 by 0 factorial. So here it will become 0 plus. Now instead of n put 1. So 1 rho raised to 1 by 1 factorial. That is 1 by 1 factorial rho raised to 1 plus. Here we have to put 2, that is 2 by 2 factorial rho raised to 2. Then 3 by 3 factorial rho raised to 3, that is rho cube. 4 by 4 factorial rho raised to 4. 5 by 5 factorial rho raised to 5 up to infinity. Now if we observe this, we will again simplify this. That is 1 by 1 factorial is 1. So we will simply write rho plus 2 by 2 factorial. So if this 2 by 2 factorial means what? 2 multiplied by 1. So this 2 multiplied by 1, 2 is getting cancelled and here only rho square is there. Then 3 by 3 factorial. So if I solve this 3 by 3 factorial, that is 3 into 2 into 1. So this 3 is getting cancelled. So here only 2 into 1. So 2 into 1 means 2 factorial. So we have to write rho cube by 2 factorial. Then in the same way 4 by 4 factorial, that is 4 divided by 4 into 3 into 2 into 1. So this 4 is getting cancelled. So we can say that rho raised to 4 divided by 3 factorial. In the same way rho raised to 5 divided by 4 factorial up to infinity. Now again we will simplify this. So from this we will take rho as a common term outside the bracket. So e raised to minus rho and inside the bracket 1 plus rho raised to 1 plus rho square by 2 factorial plus rho cube by 3 factorial plus rho raised to 4 by 4 factorial up to infinity. Now if we observe this bracket, then here we can write this term as a e raised to rho. Now here e raised to minus rho already present. So e raised to minus rho and e raised to rho is getting cancelled and only value is rho. And rho is the utility factor and that is equal to lambda by mu. But lambda is given 3 and mu, that is mu n, that is 2. So we have to take 3 divided by 2 which is equal to 1.5. Now we will move to the second question. Probability that more than 4 crews will be needed. That means we have to find out the probability for having the crews from 5 to infinity. In model 2, number of crews allowed, that is up to infinity. So we can write here, we have to find out summation of n is equal to 5 to infinity Pn. How we can write this in other way? We can write this summation of n is equal to 0 to infinity Pn minus summation of n is equal to 0 to 4 Pn. Pn, that is the probability of having n number of crews in the system. So here Pn is equal to rho raised to n by n factorial e raised to minus rho. So we will put this value. Now n is equal to 0 to infinity Pn, that is the probability for having crews from 0 to infinity. So this probability is equal to 1 because there may be possibility for having number of crews 0 and there may be possibility of having crews infinity. So n is equal to 0 to infinity, that is 1. Minus, now we will find out this, that is n is equal to 0 to 4 Pn. So how we can write this? So we have to take the value of n, that is from 0 to 4. So summation, that means we have to add. So in bracket we will write P0 plus P1 plus P2 plus P3 plus P4. Now for this calculation of P0, P1, P2, P3, P4, we will use this formula. So instead of n, we have to use this 0, 1, 2, 3 and 4. So we will write here 1 minus. Now e raised to minus rho is constant because this is not variable. So we will take outside the bracket. Now P0. P0 means instead of n we have to put 0. So e raised to 0 divided by 0 factorial. So e raised to 0, anything raised to 0 is 1 plus P1. P1, that means we have to put 1. E rho raised to 1 divided by 1 factorial, that is rho. P2. Rho raised to 2 by 2 factorial, that is rho square by 2 factorial. P3. Rho cube by 3 factorial. P4. Rho raised to 4 by 4 factorial. Now value of rho, that is lambda by mu, we have already calculated in the first question and that is equal to 1.5. So we will put the value 1 minus e raised to minus 1.5 in the bracket 1 plus 1.5 plus 1.5 square by 2 factorial, that is 2 into 1 plus 1.5 cube 3 factorial 3 into 2 into 1 plus 1.5 raised to 4, 4 factorial, 4 into 3 into 2 into 1. So we have to first solve this bracket, and then after calculation we will get the value 0.019.
Second question. A cafeteria with self-service has an arrival rate of 12 per hour. The average time taken by a person to collect and eat his meal is 20 minutes. Assuming that the inter-arrival times are exponentially distributed, how many seats must the cafeteria have to accommodate each customer with probability 0.95?
Let us understand the given data. Arrival rate is given 12 customers per hour. So we can say that lambda value, that is equal to 12 customers per hour. Service time is given 20 minutes. Now if we observe, arrival rate is given in hour, and but this time is given in minute. So we have to convert this into hour. So there are in 1 hour 60 minutes. So 20 minutes, that means 20 by 60 hours. And now how to calculate the service rate? So service rate, that is equal to 1 divided by service time. That is 1 divided by 20 by 60. That means 60 by 20 is equal to 3 customers per hour. So we can say that service rate mu is equal to 3 customers per hour. Now if we compare lambda and mu, then in this case lambda is greater than mu. That is arrival rate is greater than service rate. So this question is under model 2. It is also given that the probability of having n customers, Pn is equal to 0.95, and we have to find out the value of n. So for model 2, what is the formula for Pn? So Pn is equal to rho raised to n by n factorial e raised to minus rho. Now we will put the value where rho is equal to lambda by mu, that is utility factor lambda by mu, which is equal to 12 by 3, which is equal to 4. So instead of rho we will put the value 4, and Pn, that is equal to 0.95. So 0.95 is equal to 4 raised to n by n factorial e raised to minus 4. So this n is unknown, so we will take this term to the left hand side. So 4 raised to n by n factorial is equal to 51.9. So we have to find out the value of n by trial and error method. So by trial and error method, so we have to try here the different values of n, that is we can try here as a 2, 3, 4, 5, and we have to compare the left hand side and right hand side. So here n is equal to 7.